This is the topic about the line of symmetry and the rotational symmetry. We know one thing, that if it is a line of symmetry, then it should divide the figure into two equal and congruent parts, and they should also map onto each other. As far as the rotational symmetry is concerned, that should be rotated through any angle. It should be mapped onto the base figure there. So there are few, we have already explained it in our topic for this line of symmetry and the rotational symmetry, and now we will give some examples and we will find out the line of symmetries and the rotational symmetries and the formula for the rotational symmetry. First of all, there is the shape of square. So we are going to find out the line of symmetries for this topic. So we know that there is 1, 2, 3, and this 4. So there are 4 line of symmetries for this topic there. Now we talk about the next topic, that is the square rectangle. So it has this line of symmetry and this line of symmetry there, but this line of symmetry is not there because that is not going to map onto each other. So there are only 2 lines of symmetries through this vertical angles and the horizontal, but there is no diagonal way for that. And if it is isosceles triangle, then we know that there is only 1 line of symmetry for this part. If it is equilateral triangle, then we can have this line of symmetry there, this line of symmetry there, and this line of symmetry there. So there are 3 line of symmetries for this equilateral triangle. For this scalene triangle, there is no line of symmetry because this cannot divide it, this cannot divide it, and this cannot divide it into equal parts. So there is no line of symmetry for this part. If it is kite, then there is 1 line of symmetry for this part. No other, because A to C is not going to map onto each other, and that is not even dividing it into 2 equal parts. So there will be only 1 line of symmetry for kite. If you are talking about this rhombus, then there is 1 line of symmetry through this diagonal and 1 line of symmetry through this diagonal. So there are 2 line of symmetries for this rhombus topic, but we cannot have this line of symmetry. So it means there are only 2 lines of symmetries for this rhombus there. If it is trapezium, but it is isosceles trapezium, that means what? AD is equal to BC, then there is 1 line of symmetry for this part. But if it is generally trapezium, then it has no line of symmetry. If it is circle having center O, so you can have infinite line of symmetries for this part. You can draw anywhere the line will be passing from the center, and you can have this. So there is infinite line of symmetries for this topic of circle there. But if the circle is divided already into the 2 equal parts, then there will be 1 line of symmetry this and 1 line of symmetry this. So there is only 2 lines of symmetries when it is already given the shape of A, B, C, D. If it is in the shape of H figure there, then it is 1 line of symmetry and there is another line of symmetry. So there are 2 lines of symmetries for this symbol H there. For P, there is no line of symmetry because you cannot have any line which can divide it into 2 equal and congruent parts, and it can be mapping onto each other. For this figure U there is only 1 line of symmetry for this part. For this figure Z there, if you draw this line, then it cannot map. If you draw this line, it cannot map. So there is no line of symmetry for this symbol Z there. For this irregular shape, there is no line of symmetry because from this center, you cannot divide it into two equal parts. For this figure, there is one line of symmetry for this portion. There is no other line of symmetry for this part. And for this symbol X, there is one line of symmetry and there is another line of symmetry. So there are two lines of symmetries for this symbol X there. So this is the way that you are finding the line of symmetries for these different shapes, and you can find out the number of the values of this line of symmetries. Now we will talk about the rotational symmetry. Now for this rotational symmetry, we know that it should map onto the base figure again. Then it has the line of symmetries. So for this, we have this, that the angle of rotation is equal to 360 degrees over order of rotation. So we can use this formula for this rotational symmetry for our figures, this one. The first figure, the angle of rotation, if we have to find out, we know that the angle of rotation is equal to 360 because there are four lines of symmetries there. So we can divide it into rotate it into the four different ways. So it should be divided by 4, that is equal to 90 degree. So if you rotate this figure through 90 degree, then after 90 degree, 4 times rotation of this figure A, B, C, D, it will be mapped onto this again figure A, B, C, D. So the angle of rotation will be 90 and order of rotation is 4 there. For this rotational symmetry of this rectangle, it should be 360 divided by 2 because there are two order of rotations. So it should be equal to 180 degree. So if you rotate this figure through this center O, after 180, it will be mapping into its base figure. And after again rotating it through 180, it will be back to its original figure A, B, C, D. For this, there is one line of symmetry, so that means 360 divided by 1, so it should be equal to 360 there. So if it is rotated to 360 degree, it will be again into its base figure. So the angle of rotation will be 360. That is 360 divided by 3 because there are three order of rotations. So it should be 120 degree. So if you rotate this figure after 120 degree, each times and 3 times after rotation, it will be back to its original shape. So this will be the rotational symmetry of order 3, and the angle of rotation will be 120 degree there. So you have seen it in this examples that if there is no line of symmetry or there is one line of symmetry, then the angle of rotation will be 360 degrees, and otherwise, how many times then there will be the line of symmetries, it should be divided by the 360, and that is the angle of rotation for these figures here. So for this scalene triangle, because there is no line of symmetry, so the angle of rotation is equal to 360 divided by 1, and that is equal to 360 degrees. After 360 degrees, it will be back to its original position. For this guide, there is one line of symmetry, so angle of rotation will be equal to 360 divided by 1, or that is equal to 360 degrees. For this rhombus, there are two lines of symmetries there, so its angle of rotation is equal to 360 divided by 2, or it is 180 degree there. So after 180 degrees, if you rotate it 2 times, then it will be back to its original shape A, B, C, D. There is one line of symmetry for this part, so angle of rotation is equal to 360 divided by 1, so that is equal to 360. So after 360 degree completely, it is rotated, then it will be back to its original position. For this topic of circle, there are infinite line of symmetries. So angle of rotation will be equal to 360 divided by n. So it depends upon the value of n, that how many times there are line of symmetries you want to find it out for that part. Then for this figure, circle is already bisected. There are two lines of symmetries. So angle of rotation will be 360 divided by 2, and that is equal to 180 degrees. So if you rotate it through 180 degrees two times, then it will be back to its original shape there. For this, the angle of rotation, because there is two line of symmetries, so angle of rotation is 360 divided by 2, and it is 180. So after 180 degrees, if you rotate it two times, it will be back to its original shape there. There is no line of symmetry, so angle of rotation will be 360 degrees. There is one line of symmetry, so angle of rotation is again 360 divided by 1, that is 360 degrees there. There is no line of symmetry, so angle of rotation will be 360 divided by 1, and that is equal to 360 degrees there. There is no line of symmetry, so angle of rotation will be equal to, that is 360 degrees. There is one line of symmetry, so angle of rotation is equal to 360 divided by 1, and that is equal to 360 degrees there. There are two lines of symmetries, so angle of rotation is equal to 360 divided by 2, and that is equal to 180 degrees for this part. So you have seen it there that the rotational symmetries is according to the angle of rotation. If there is no line of symmetries or there is one line of symmetries, then it is the angle of rotation will be 360 degrees. If it has two lines of symmetries, then the angle of rotation will be 180 degrees. If it has four lines of symmetries, then the angle of rotation will be 90 degrees. And if it is having infinite line of symmetries, then the angle of rotation will be 360 divided by the number of line of symmetries for that part there. So this is the way that you can distinguish between the line of symmetries and the rotational symmetries for the different examples of this.